Okay, so today we are going to start with the concept of circular motion. And this is almost the end of the chapter of the forces. Then we will start with a new chapter that is work energy power. Only equilibrium, center of mass, that is a general concept related to the body. And mostly of you already know about that concept. So that was not much very difficult. We only need to discuss about that. What are the important points that make the body stable? But today we are going to talk about the circular motion. First of all, we know that if we talk about any daily life circular motion example, so let's suppose if we just tie a stone with a thread. Let's suppose if we are having a stone and we just tie it with any thread, and let's suppose if we start applying force on this object, so it will move in a circular path, right? And this length of the thread will the radius of the circle because it is at the center, and from the center to the boundary or to the any specific point at the boundary on the circle is known as the radius. But the concept is, let's suppose if we want to write the definition for the circular motion. So circular motion actually happens when body moves in a circular path with constant speed. When a body moves in a circular path, in a circular path with constant speed. So this is the basic definition of a circular motion, right? And we know that velocity, or if we talk about the speed is a scalar quantity. But let's suppose if we want to study about circular motion, so if we consider any specific circular part of the circular motion, let's suppose if we consider and body is actually moving circular path. Let's suppose if we consider a whole circle and try to break that whole circle into small intervals. So each interval will be like a small line. Let's suppose if we consider this interval. So you can see that if we just start breaking whole circle into a small interval, so each interval will act like a straight line, right? It means that at every point, at each and every point of the circle, the direction of the body actually changes as compared to the previous direction, right? Let's suppose if we compare the direction, or if we want to find out the direction at this specific point, and body is moving in downward direction and rotation of the body is clockwise, like body is actually moving in this direction. So this will be the direction of velocity, like this. And because of the tension in a string, because the string is connected with the body or that circular or spherical object, so always force will act towards the center of the circle, right? This will be the tension force, tension in a string. So this is the force that is actually tension, because whenever we start to talk about any thread or any rope, so there will be a force known as the tension. So tension will always try to keep the body in the circular path, right? Because that thread helps the body to move in a circular path, and that whole motion is known as circular motion. And if we talk about any specific point on the circular path, so at each and every point we observe that the direction of velocity is like the tangent to the circle, right? Let's suppose if we want to write the direction for the velocity or the direction of the body, let's suppose if we are just moving this object in a circular path and suddenly this string breaks, so in which direction body will move? Let's suppose at this specific point body is moving in this direction, clockwise direction. And let's suppose at this specific point the string actually disconnects from that body. So in which direction body will move? Any idea?
The tension is gone, so it will like go straight from like the path it
Yes.
was on.
So body will always move in the straight line. It follows a straight path. Let's suppose if it breaks over here, so it will straight move like this. So let's suppose if we consider a circle. So in any circular path, if body disconnects from the string, so it will always move tangent to the circle, right? So we can say that direction of the body is always tangent to the circle. Suppose if someone asks you to find the direction on a circular path at any specific point, so you can easily find out just marking a tangent to the circle, and that will give you the direction of that body, right? And we discussed that body will always move with a constant speed. So speed will remain constant because we know that we are following a specific regular circular path. So our speed might be constant. But the problem is that direction of body is changing at each and every point, right? So we may just add one more point over here, but the direction of body is actually changing at the interval or point. Okay, in kinematics or in motion chapter, we discussed that if we compare velocity or speed with respect to time, so what will be the new quantity we derive from that concept? Velocity over time is equals to acceleration, right? So let's suppose if body starts moving from this specific point to any other specific point like this, so it will take time to move from point number one to point number two. So it will also take time. And when we compare the velocity of the body with the time, so we will get the value of acceleration, right? So now we have two new concepts related to that circular motion. The first one is known as centripetal acceleration. And in definition, in exams also, they used to ask that if body is moving with a constant speed in a circular path, so why there is a concept of centripetal acceleration in that? So why centripetal acceleration will produce in a circular path of a body?
When the string disconnects.
Let's suppose body is still moving in a circular path, and still there is a centripetal acceleration. Always will be there a value of centripetal acceleration at each and single point on a circular path. So why there is a value of centripetal acceleration? We know that there is a constant speed of the body.
Because of this direction, because it keeps
Direction.
changing each and
Yes.
every second.
Yes. So that's why in definition we used to write the constant speed, because we know that speed only shows you the magnitude. That's why I used to write the second line that direction of body is changing. So due to that change in direction, centripetal acceleration will produce, right? So for that purpose, you need to write the reason that velocity is a vector quantity, because rate of change of velocity is known as acceleration. So we know that velocity is a vector quantity, So due to this change in direction or due to change in direction of body in a circular path, due to change in direction, centripetal acceleration will produce. Okay, one more important thing. There is a specific formula for centripetal acceleration, but in your syllabus, uh, we can say that in your exams, they are not going to assess your concepts according to the formula, but that formula will help you to just think about the quantities that in circular motion, what are the factors on which centripetal acceleration depends, because those factors which actually affects the centripetal acceleration, those are included in your syllabus, but formula is not included. I will also send the screenshot, or you may check in your syllabus that it is mentioned that formula is not going to be assessed in your exam. They just mention the formula because with the help of the formula, it is very easy to understand that on which factor centripetal acceleration actually depends. So the formula is equals to AC centripetal acceleration equals to velocity square over r. So this is the formula for centripetal acceleration, but always remember that there is no numerical question related to this concept in your exam and in your syllabus, right? Only this formula help you to just know about the factors on which it depends. And why we are using this V square in the concept, we know that we are using single body. And when we talk about a single body, so always we discuss that there will be a single velocity of that body, right? So why we use V square in this concept? Or why we use v square in the formula of centripetal acceleration? Any idea?
No.
Okay, let's suppose this is also not important, or it is not also included in your exam, but it is important to know that why we use v square. We know that there is a single velocity, so why v square? Maybe there are two velocities or two different concepts of velocity included in that. So let's suppose again, if we consider a curved path and body is again moving on a circular path. So let's suppose uh, one we one direction that we discuss, which is always tangent to the circle. So that is the direction that we already discussed about. So one is that velocity that actually is always tangent to the circle, and the second one is that is moving with the circular path, right? Because actually body is moving in a circular path, not in a straight line, but at each and every specific point, the direction of the velocity will, or the direction of the body will always tangent. Because of that string, body is not able to move outside the circle line. Okay, so actually the concept of v square is, this line represents you the concept of tangential velocity. Tangential velocity means velocity which is always tangent to the circle, right? And the second one is the angular velocity, which is actually moving in a circular path, because when body moves in a circular path, so it will always suspend any specific angle, right? So there will always an angle in a circular path. We all know that in circular direction or in circle shape, there will always a concept of angle there. So that's why we use another concept of velocity that is known as angular velocity, right? And we also studied the concept of resultant force, right? So actually there are two different forces acting on the body. So the final direction of the body, or the final force that is acting on the body, is the resultant force, right? So that's why two different velocities actually, or we can say that two vectors of velocity quantities actually acting on the object, but we only consider the resultant one. So the resultant one is equals to v square, right? So that is the concept of v square. Okay, any confusion?
Can you repeat? I was writing down the notes. Sorry.
Okay.
Yeah, me too.
Okay, so basically the concept of resultant force, right? We already discussed the concept of resultant force. A resultant force is the third force, we can say that. that actually drives from the other two forces single object, right? So we already written that velocity is a vector quantity. So basically there are two vectors of velocity acting on a single object, right? One is the tangent one and second is the angular one, right? So because of that two vector, body will move in the direction of resultant force, right? So that is the final velocity with which body is moving in a circular path, and that's why it is equals to v square, because that final velocity is the combination of two vectors, the tangential velocity and the angular velocity, right?
Okay.
Okay, I'm
Sir,
only yes,
what is R in the formula?
yes. So now
The
the
radius.
important thing is yes, that actually the radius or the length of the string. So that is the important thing that we need to discuss over here, because in your exams they ask you about that. Let's suppose if you want to increase your centripetal acceleration, so we know that we need to increase the radius, right? Sorry, if we want to increase the centripetal acceleration, so we need to decrease the radius.
Decrease.
Yes, because it is inversely. So we can say that centripetal
So,
acceleration.
sir, is the formula v squared over r minus 1?
Uh, v square over r minus 1. No, we are not going to use the formula because that is not included in our exam. This is just
No, no,
for
I'm just
your
asking
reference.
for general
No,
purpose.
we are not going to use that one also, because at this particular stage at IGCSE level, we only need to talk about the basic thing. So we only use single formula for the reference, that is v square over r, right?
All right.
So centripetal acceleration is inversely proportional. Means let's suppose if we increase the value of r. Okay, so this is the first factor, which is actually related to the radius. R is the radius of the circle, or we can say that the length of the string, right? And it also depends upon the square of the velocity. So if we increase the value of speed, so acceleration will also increase. That is simple concept, right? Because acceleration is the rate of change of velocity. So if velocity increases, so acceleration will also increase, right? So any confusion till now?
No, sir.
Okay.
Um, I have a
So
confusion.
yes.
What's the difference between tangential velocity and angular velocity?
Okay. So actually we discussed that whenever body starts to move in a circular path, let's suppose in this direction. So due to that force of a string, body will move in a circular path, right? But let's suppose if the string breaks at some specific point, or just we can say that string is just come out from our hand. So in which direction body will move? So body will always move in a tangent direction, right? This is the point. So it means that there are two vectors or forces, we can say that in simple words, that actually there are two forces acting on a body. One is the tangent, one is in the direction of tangent velocity, because there will always a straight component or velocity in a straight line on a body, that is known as tangent or tangential velocity. So tangential velocity is for the tangent direction of the body, right? And the angular one is for the body moving in a circular path. So that is the concept of tangential velocity. That if a string breaks at some point, or if a string just come out from our hand, so body will not move in a circular path anymore. It will just move in a tangent direction, right? You may also try this experiment. Just tie anything with a string and try to
Oh,
move in a
yeah.
path. And when you suddenly just
Leave it. It just goes
yes.
flying in a
So
straight
it
line.
will always move in a straight line, not in any circular path, right? So that is the concept, because there is a force that always acts, or there is a component velocity that always tries to move that body in a tangent path, right? So that's why I mentioned that at each and every specific or small interval of circle, there is a straight line, right? if you consider this one, so this one is always like a straight line. So that's why there will always a straight direction or a tangent direction of velocity in a circular path, right? If we talk about the forces, so there is a concept of centripetal acceleration. So there is also a concept of centripetal acceleration. So actually centripetal force is a force that keeps the body in a circular path, right? So actually, so that there is a string which is connected with the body, and that string is responsible for that circular motion of the body. So the resultant force that actually acts on the body, that keeps the body in a circular path, so that force is known as centripetal force, right? And we know that what is the formula for force that we derive from Newton's second law? F equals to
Mass times acceleration.
mass times acceleration. So we know that from Newton's second law, the formula of force is equals to mass time acceleration, ma. But in this particular topic, we know that there is a concept of centripetal acceleration, right? So centripetal acceleration means we need to write AC, centripetal acceleration. So centripetal acceleration means we need to substitute this value or the formula for centripetal acceleration. So your final formula will be equal to FC V square R, right? Because we know that centripetal acceleration is equals to V square over R. So we just replace the value of
Sir, I
AC.
have a question.
Yes.
What is this? This part?
Okay, this is just equation. We may just write it 2. Equation number 2, equation 1. This
Oh,
is just
okay. The
for the
number.
reference.
Oh,
Yes.
oh. I thought it had like significance
No,
to the
it is
formula.
actually just like it was written in the book for the reference that refer to that equation. So we actually just substitute the value of equation 1 into equation number 2. So our final formula will be equal to mv square over r. So this is the final formula for centripetal force, right? And now we can easily just interpret from the equation that force is actually depends upon the mass, right? Just like the previous one, F equals to ma. So the centripetal force also depends upon the mass of the body. Second thing is the radius that we already mentioned, that centripetal acceleration is inversely proportional to r. So same goes for the force. We can simply write in a short note that Fc is directly proportional to the mass. And the second thing is centripetal force is inversely proportional to the radius of the circle, right? So these are the two factors, because in your exams, they only ask you about the factor there. Let's suppose if we need to increase the centripetal force, so which factor will affect the body? So you need to know the formula, because they are not going to ask about the calculation part for the formula, but still they ask about the conceptual concept related to centripetal force and centripetal acceleration, right? And one more important thing in this topic is that is related to direction of resultant force. Direction of resultant force. So we already mentioned force, right? That is with the tension, or we can say that that is same in the direction of tension. So for the resultant force, or for the direction of resultant force, we can simply say that that the direction of resultant force will always towards the center of the circle. Why? Because we already discussed about the centripetal force. So centripetal force is responsible for the circular motion of the body, right? So it means that body is actually trying to, because of inertia, actually trying to leave that circular path, right? But because of that string, because of that tension, body is not able to move out of the circle. So that's why we can say that the direction of resultant force is always towards the center of the circle. Any confusion?
No.
So this is the only and the
No,
complete
sir.
concept related to the circular motion. There is nothing they will ask about circular motion in your exam, because they only ask you about in MCQs. Mostly 90% you observe in your worksheet that there are multiple MCQs related to that circular motion, and all are having the same concept, that what is that will be the direction of resultant force, right? They will never ask about the formula of centripetal force or acceleration. But if they ask about the factors, so these are the only factor. That's why I used to write the formula, but always remember they never ask you about calculation part. Okay.
Okay, sir.
Sir, can the centripetal force exist without a rope or any tension?
Actually, let's suppose if
Yeah, yeah,
we
it
are
can.
just moving around a curve, right? Or car is taking a U-turn, so always there is a centripetal force, right? And that is because of the friction of the road, right? The engine force. So then we need to draw the vectors, because car is actually taking the turn. So again, the same component. One force is acting tangent to the circle, right? And the friction is acting in the opposite direction, right? And actually we are trying to move, let's suppose if we try to move in a circular or in a curved path like this. So if we just take a curved path and car is moving towards right hand side.
So instead of car, you can use what do you call motorbike.
Yes, anything, any
That's
vehicle
a better example.
that is actually taking the turn, that question is also included in our exam. So actually one force, that is the engine force, now that force will be tangent to the circle, right? And the frictional force act in the opposite direction, right? Forces are actually balanced, or slightly less, friction is slightly less than the applied force that we discussed in the previous topic. Now we know that there is no opposite force in specific direction, right? Let's mark it with C. So there is no force acting in the direction of C, right? So that's why a car is taking a turn. So again, we take the reference from the circular path, that the resultant force will always act towards the center of the circle, right? So if there will be no string, no rope connected, so still there will be always a resultant force, and that resultant force acts towards the center. Okay.
Okay, sir.